let's see what we got started out with, our problem of the day. This one a little bit lower keyed than the past few that we've had. This one says find the greatest common factor, that's called a GCF, of 60, 72, and 96. So once again, we're going to find the greatest common factor of 60, 72, 96. Whew, some big numbers you say. Well, let's see if we can figure out a way to tackle this problem. Let's take a look at this. As you see, we've got three numbers involved. So many times we look for a GCF, we're always thinking about at least two, but three is pretty commonplace also. And these numbers look a bit intimidating. So let's take and write them down here. You can write them down at home. And I'm going to put them right there, just three of them. That's all we got. And we're going to talk a little bit about what do we notice here as we try to break them down. Because remember, when we're talking about factors, we're trying to break these things down into smaller, workable pieces. So let's see. I'm going to do what looks like an upside down division sign, but I kind of like doing this. I do. I really do. We have three even numbers there. And hint, hint, when it's an even number, we can divide through by 2. Now, once I divide through by 2, my numbers are going to all of a sudden become much smaller, and they're going to be much easier to work with. And who knows, we might have another even moment. But you say, well, Ernie, what are we going to get? Well, we're going to divide 2 into 60. That's going to go 30. We're going to divide 2 into 72. It's going to go 36 times. And whoo, 2 into 96, think about it. Half of that is 48. So what we did, we basically halved everything, and all of a sudden the numbers look a little bit more manageable. At least they do to me. All right, I like the look of them. Here. Let's see what happens. They're even still, aren't they? So let's go and do another. And notice I keep making these little numbers to the side. They're going to be important to us in just a second. Just be patient. Dividing 2 into 30. We're going to halve everything. Like I said, it's all even, so it's going to come out nice and even. And we have 15, 18, oh, and on the end, divide 2 into 48, I get 24. Now we have, just two numbers that are even. We have a third number that says it's 15. So where are we going to go? Where are we going to go with this? Well, we're going to look and see what we can do. I notice, common thread here, it looks like they are divisible by 3. Now, a test to see if divisibility by 3 is if you add the digits. No matter how big the number is, but if you add the digits, that'd be 1 plus 5, and you get a number that is divisible by 6, that number 15 is also divisible by 3. Did I say divisible by 6? Sorry, divisible by 3. I don't know where I'm looking ahead for 6. We'll find it. But let's put a 3 out there. Oh, we had 6 and divisible by 3. We'll get there. If we add 1 and 8, that gives me 9. How about it? 9 is divisible by 3. And how about it? 2 plus 4 gives me 6 again, divisible by 3. So all of these have that characteristic that they're divisible by 3. Let's do it. Let's divide them by 3 and see what happens. I get a 5. I get a 6 right next to that. And then I have 8. Now I'm looking how close these guys are together. And I'm going to ask myself, are we going to have a common factor, a GCF? We do. But the only number that's going to divide into these is 1. Now 5 is a prime number. So we always start thinking about, well, 5 won't divide into 6, and it certainly won't. It won't divide evenly anyway, and it will not divide into 8 evenly. So we're looking for nice numbers, integer factors here that are integer remainders, integer values, all right, that we have left over here to get to. So let's take a look at what we found. We found 2, we found 2, we found 3. So here's the idea. To find the greatest common factor, well, yeah, we found 1. Don't want to forget about 1. We are going to take 2 times 2 times 3 and see what we get. Again, times 1 isn't going to affect the answer here. We're going to multiply those 3 numbers that we've got off the side, and that gives us 12. My question is, can we divide 12 into 60, 72, and 96? I hope we can. If I divide 12 into 60, it goes 5 times. If I divide 12 into 72, it goes 6 times. And if I divide that 12 into 96, it goes, my goodness, 8 times. They're your final numbers, 5, 8, and 6 down through there. Now, what you say would go with that? If we had started with 12 here, we could just run this thing right through. Usually, however, with bigger numbers, it's almost kind of a little exploration. And it's nice to dabble in the evens, because as long as you can keep running 2's in there, you can keep making those numbers smaller and smaller and smaller and much more manageable. Once you get to this point, start thinking about a 3 because, well, I know 3 goes into 15 5 times. I know 3 goes into 18 6 times, and it goes into 24 8 times. If you didn't know that, you could do that little add the digit trick. Like I said, add the 2 digits. In this case, they're 2. And see if they will divide evenly by 3. And they did. Remember, this one went 1 plus 5 gave us 6. Here we had 1 plus 8 gave us 9. And over here we had back to 6. They were all divisible. So there's your tricks. There's your answer. G, C, F, 12. How about it? All right.